Okay, we've been solving systems using graphing, and so we want to look at the algebraic methods for solving systems, and we're going to start by reviewing solving system using substitution. And our first step is to write both equations in slope-intercept form. So we want to write the equations in y equals mx plus b, just like we did when we graphed them. Step number 2 is to set both equations equal to each other and solve for x. And then step number 3 is to substitute the x value found in step 2 back into one of the equations solved in step 1 and solve for y. So let's look at an example. My system is y equals 3x minus 5 and 8x plus y equals negative 16. Step number 1 says to put them in slope-intercept form. We can tell that the first equation is already in slope-intercept form, so we're going to take the second equation and put it in slope-intercept form. We'll do that by subtracting 8x from both sides, and so I have y equals negative 8x minus 16. Step number 2 says to set the two equations equal to each other. Well, if both the expressions 3x minus 5 and negative 8x minus 16 are both equal to y, then they must be equal to each other. So I have 3x minus 5 equals negative 8x minus 16. So I want to solve this equation for x. I'm going to add 8x to both sides, so I get 11x. I'm going to add 5 to both sides, so I get equals negative 11. I'm going to divide both sides by 11, and I get x equals negative 1. Now step 3 says to take my answer from step 2, plug it back into one of the equations in step 1, and solve for y. So I have y equals 3 times x minus 5. So y equals negative 3 minus 5, so y equals a negative 8. So it appears that my solution is negative 1 comma negative 8. Okay, so we're going to check it to make sure. I'm going to take my solution, I'm going to plug it back into this for a second equation, put negative 1 in for x, negative 8 in for y, and do I get negative 16? The answer is yes. I put negative 1 in for x, negative 8 in for y. Is that true? The answer is yes. It's true for both equations, therefore this is the solution to my system. Now here are 2 examples. I'd like you to try these 2 examples, solving them using substitution. Bring those in class. See you tomorrow.